GCSE Physics boosters, resultant forces. Resultant forces, when you add forces together, you get a resultant. So one person can pull with a force of 300 newtons, so two people together can pull with a force of 600 newtons, and that 600 is called the resultant force. When you add them together, the resultant force is 600 newtons. Pretty straightforward. So, can you work out what the resultant force is in these cases? So, if you combine these pairs of forces, what is the resultant force? Could you work it out? Pen and paper, and I'll show you the answer in 3, 2, 1. So, top left, 50 plus 50 is 100, easy peasy. Bottom left, 60 plus 20 is 80. Now, the two on the right, what we need to do with vectors is if one direction is positive, for instance, in this case, left to right is positive, then the opposite direction is negative. So if this force is 120 newtons, top right diagram I'm looking at, then in the opposite direction, that is going to be minus 30. So the resultant force will be 120 minus 30, which is 90. And then the bottom right diagram will be 50 minus 70, so the resultant will be minus 20. So if one direction is positive, then a force in the opposite direction will be negative. Something else to notice on these diagrams is that my arrows to represent the vectors, I've drawn them to scale approximately, and that gives you an indication of their magnitude, how big they are. If you look at the top right diagram, the 120 newtons arrow is much bigger than the 30 newtons arrow. Okay, so the size of the vector can give you an indication of its magnitude. These are called free body diagrams. Now, a free body diagram just shows the object that you're interested in, and it shows the forces acting on the object. So the cup on the table, I haven't drawn the table. I've just drawn the cup and I've drawn the forces acting on it. The ladder leaning against the wall, I haven't drawn the wall. I've just drawn the ladder. Maybe on these diagrams you can figure out what these forces are. In most of them I've given you the first letter as a clue. But anyway, these are called free body diagrams. You know what a free body diagram is now. Right, this is where it gets interesting. What is the resultant of these two forces? Or rather, how would you go about finding the resultant of these two forces? Now, the way that you would be expected to do it would be to do a vector diagram. There are a couple of ways of doing it, but the way that you would be expected to do it would be with a scale diagram. Now, a scale diagram, as in you would draw probably on graph paper an arrow representing the 400 newtons force, and an arrow representing the 300 newtons force, and then you'd complete the rectangle and draw the diagonal. Okay, you would do a scale drawing. So the easiest way of doing it is on graph paper. Oh, this is easiest on graph paper. It's not the easiest way of doing it, but if you're doing a scale diagram, then you do it on graph paper. Draw the forces in the X and Y directions to scale. For example, 1 centimeter could be 10 newtons, for example. Complete the rectangle, draw the diagonal, measure the size of the diagonal with a ruler, and then work out the magnitude of the resultant. And you should get something like 500 newtons because it's a 3, 4, 5 triangle. And then you can measure the angle with a protractor if you need to know the angle as well. And yes, there is this fella here. Do you know his name? I think he's called Pythagoras. I think he knows a more accurate way of doing it, but we'll leave him alone. Now, consider this. This is the opposite of adding vectors together. Here's a tractor pulling a log. Now, looking at it, the tension in the cable is 3,000 newtons, but the force, the horizontal force, isn't going to be 3,000 newtons. It'll be less than 3,000 newtons. Okay? How much of this force is horizontal? Well, what we need to ask ourselves is the tension, we say, has got vertical components. Well, it's got a vertical component and a horizontal component. Okay? This tension here, which is in that direction, it's got a horizontal component and it's got a vertical component. Okay? That's the horizontal component, that's the vertical component. And the question that this question is asking for is, what is the horizontal component of this force? How do you find that out? Well, what two forces would you add together to get 3,000 newtons at 25 degrees? How could you work that out? Again, there's a couple of ways of doing it. You probably won't be asked to do this, but you could do it on graph paper. Again, there's your 3,000 newtons force at 25 degrees. Do a scale diagram. So perhaps maybe for 3,000 newtons, you would do 30 centimeters. Draw it, draw the rectangle, and then you can measure these two forces with a ruler in centimeters and then change it to newtons. So for example, if you did it accurately, you should get something like that would be 27.3 centimeters, which is 2,730 newtons, and that would be maybe 12.7 centimeters, which is 1,270 newtons. Okay? Would you be asked to do this in an exam? To be honest, it would be a hard question, but it does say you need to understand that forces can be split into components. If you're adding together component plus component equals resultant, well, this is the opposite. You start with the resultant and you work your way backwards. You say, well, what are the two components of this force? Have a go at this. A girl has a mass of 60 kilograms, so her weight is 600 newtons. Now, I've done a vector diagram. The blue arrow is her weight, and I've split it into components. Which of those vectors on that diagram represents the component of her weight down the slope? And hopefully you'll realize it is that one there. That is the component of her weight down the slope.